Hello there, Embedded Monk here. Today is Embedded Adventure Day 8. Yeah, Day 8. And in previous series we made serious progress. We finally, we made it. We connected ESP32 to Wi-Fi. Finally, this tiny thing got an IP address, and that is amazing. So cool. And in previous series, I also mentioned that I actually gave up after trying to connect the ESP32 for like 3 days straight to Wi-Fi. That I actually watched this guide and actually done just what it told me to do, but actually. Um, it also told how to receive and send requests via TCP from the ESP32. And I think we should also spend some time to gather some theory before we will be able to code anything. So today will be just some kind of like my exploration of this topic, and of course with ChatGPT and all that too. So without further, let's do this. Yeah. Okay. So first of all, yeah, I'm gonna just open like the new dialog here, and also I'm gonna just explore some materials. Maybe I have some materials about the like TCP connection or something like that. Maybe in random nerd tutorial. I guess. Well, random nerd tutorial is actually good, but they use Arduino IDE and I don't like it. I actually want to program everything using just plain ESP-IDF. So web server. Will they use the Arduino? Oh, whoa, 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 whoa! Spoiler alert! They want to do just exactly what I actually want to do. They want to make these like remote LED blinking. So I don't really want to watch it because there's like spoilers here, and they use Arduino IDE, so I don't care. Okay. So, first of all, yeah, I remind you guys I'm a complete beginner in embedded systems, so don't judge, please. Okay, so I'm just gonna quickly look at the previous thing here. Oh, damn. Okay. No, that actually was the. Well, okay. Let's use it. Let's use it. Let's use this dialog. Okay. So first of all, how can ESP32 receive and send packets via TCP, for example? I guess it would tell me something about sockets, but I want to know how they work internally, like on ESP32. I don't really. I work with them on like with the Windows library. There is a Windows library called WinSock, I guess, but ESP32 is a whole different world. So let's just ask him about it. Like any sockets. I don't know. I receive TCP packets using standard BSD style sockets. Oh, so we can use like the socket library like in Linux. Okay. Windows or any POSIX compliant system. This is part of this is part of the LWIP TCP/IP stack that runs inside ESP32. Let's break it down but deeply. Okay. Okay, so we'll have just gonna okay moment. Close Wi-Fi driver layer 2 LWAP TCP/IP stack. Okay. IP address behaves like a normal IP device. Open TCP sockets, open UDP sockets, do DNS, HTTPS, TLS connections. Okay. So basically everything just the same as doing some web stuff in C on just a regular personal computer, I guess. You just open socket and fill the buffer, etc. So I'm just gonna ESP-IDF sockets. Okay. Damn, probably gonna install Wireshark to actually explore how the ESP32 sends something. Sockets API going cross-platform TCP/IP sockets API that originate in the So any like examples here? No examples, no API. Okay. Yep, so today guys will be some kind of theoretical video as you may also get might already have guessed. Yep. Sorry for my bad English. But I'm just documenting the progress here, so I'm kind of like not every video is like very entertaining probably, but I just want to actually document it to see how I grow, and also maybe to inspire you to grow with me. That would be cool. So if I somehow motivate you, that's also pretty cool. So okay, so what did it told me like where all those functions live, like the socket, this structure, or should I just import them from this like here LWIP apps what? Okay. By the way, we can look at the TCP server, I guess. Maybe. Oh, that's just a plain example here. Okay, let's look. Let's look just to see how it can be created. Not how it should be created, but how it can be created, of course. So they import bunch of stuff, and here we go, LWIP sockets. Okay. Retransmit. Server task. Okay. damn, so they actually implement the TCP like straight away. Like they implement the retransmission logic, they implement the like connection logic here. Okay. They do it like for FreeRTOS, I guess. So they just create the task here with some params and it's just run in parallel, I guess. Okay, is there any way to work more high level? So to actually work on the HTTP, so the on application level, not on transport layer. Is there any way like HTTP API ESP32? Come on, HTTP client provides a set of APIs for making HTTP requests from ESP-IDF applications. The steps to use these APIs are as follows. Okay, HTTP client init. Sorry guys. Okay, so we have a function that creates a ESP HTTP client handle. And we actually already know what handle is. Yay. This is that thing that we register to react on certain event. It's on certain event ID from certain event group with certain function. And with certain instance, yeah. That we can modify. Okay. All operations of the ESP HTTP client here, opening the connection, exchanging data, and closing the connection as required. Okay. Based on the given client configuration, all operations of the ESP HTTP client, opening the connection, changing data, and closing, clean up. Okay, let's just try to experiment a bit. So first of all, this is a total mess here. Probably what smart people do when they have a total mess, they just create a function. Basically, yeah. So let's just create a function of the connection. Yep. And let's call it connect to Wi-Fi. Yep. Let's call it straight away. It will take the SSID, it will take password. What else? Currently I really don't know, but okay. I guess this stuff is just basic stuff, so we probably won't include these ones. And this one as well. But I guess we should provide these into the okay, into this function. Probably gonna be a little bit messy, but okay. The scan logic, I guess that was pretty fun experiment, so okay, but we just don't need it for our application, I guess. So we're not making a router here or something else. And let's just insert here the SSID and the password. Yep, okay. And all the like debug messages like wrong password or connected and got IP, they are actually will be handled here in Wi-Fi event handler, so we don't need to like make any of them here, any of prints and all that stuff. And I guess we can delete all that comes after the event loop default. So let's just plainly delete it. But I guess till this time, yep, and just replace it with the connect to Wi-Fi. Okay. Let's just pass it here. Like, I don't care, guys, if you steal my password. I won't even tell you not to steal it. You will steal it anyway. I'm just telling you this in every video. Okay. Let's just check that nothing has changed and everything works. One moment, guys. I just forgot to connect the ESP-32. Okay, let's just connect it. Here we go. Totally good. Okay, let's now just build it straight away. Okay. What? Okay, he's not able to compile a. Oh, I'm in the wrong directory. I understand. Okay, let's go to embedded adventure and try again. What a fascinating build system, guys. This IDF.py. What? Okay, say the missing braces. Where? Where do I miss the braces? Around initializer? Where here? Are you sure? That worked perfectly yesterday. Oh, or like initialization of unsigned char from const char. That's what I don't like here. That's a very dumb question, but usually the const char can be casted to the unsigned char static array. Yeah, but not here, I guess. Huh. Initialization of unsigned char from const char pointer makes integer from pointer without a cast. Well, seems reasonable, but it worked fine with when I was just plainly just you know what? Yeah, let's just make it the old way. Let's just comment it. comment in it again. Okay, and just memcpy them. Yep, the string is already included, so less work. Configuration.sta.ssid, then from ssid, and then from how much ssid. Yep, just like that, and the same for password. Yep, less efficient, but who cares? Who cares? Okay. Probably it will now tell me that I like discard const qualifier somehow. Well, actually no, it just casted perfectly. Yep, pretty cool. One moment. Okay. And let's check. Monitor. Should be basically the same. So we should, yeah, we connected perfectly. Okay, so now let's try to init some HTTP client right here. HTTP client and send some requests. Okay. So I just want to look how this works. Client is start an HTTP session. This function must be the first function to call, and it returns an ESP-HTTP client handle T that you must use as input to other functions in the interface. This call must have a corresponding call to ESP-HTTP client cleanup when the operation is complete. Okay, so for every operation we should init and deinit the HTTP client. Well, probably we can do it more efficiently, but okay. And what is configuration? Let's just check. What does it have? URL, host, port. Okay. The information of the URL is most important. It overrides the other fields below, if any. Okay, but we actually can just discard them, I guess. Okay. So then host, port, username, password, if there any HTTP authentication. Okay. So let's just create this. Client config T. So the HTTP config will be here. Where should we pass our HTTP request? Where should we send our HTTP request to get a reasonable response? I don't know, google.com. Just google.com. Well, at least it can actually respond to us with the OK error code or some other error code like 404 or 200, etc. So let's just put it like, I don't know, http dot slash slash. I'm not crazy yet. Yeah, I'm not. Google.com. Okay. We're gonna pass it here to instantiate in the client, ESP HTTP client init, and it will return us ESP HTTP client handle, just like that. So the HTTP handle here, a ESP HTTP client init, where we'll pass the address to HTTP config. Alright. So let's assume we initted the HTTP client correctly. What's next? ESP HTTP client perform. Invoke this function after client init, and all the options calls are made. It will perform the transfer as described in the option. By the way, certification card line. Length of the buffer pointed to by cert_pem. There's actually a lot of things here. HTTP method, so the method here, like get post or something like that. Well, it will default to get method, so probably we shouldn't really care. Okay, let's try this out. So the method is get, then we just call the ESP HTTP client perform, ESP HTTP client perform, alright, and pass there the handle, HTTP handle. Okay, should we get some response here? Okay, unsuccessful fail. I guess I would like to actually see the HTTP response, like with the code, with error code. So not the ESP error code, but the HTTP error code. Like, okay. As we go on the same. Turn performs the entire request in either blocking or non-blocking manner. Request, okay. Okay, but how to actually get the header? Request header, but how to get the actual response? Or I wonder. To read larger data chunk, this is a helper API which internally calls HTTP client read. Get status code. Oh, here we go. Get HTTP response status code. That's perfect. That's what I actually looked for. ESP HTTP client get status code. Yep. So HTTP code, ESP HTTP client get status code from this handle. Okay, let's just print flag Google answer it with send the code. Yep. HTTP code. ESP HTTP client init. Okay, then we're performing this operation that way. Then we're gonna go. And one moment, guys. I guess there is HTTPS here. Yep. Yep. Not the HTTP. So let's try. Seems pretty easy, but who knows what bugs may we encounter. Unknown type. Yeah, I probably forgot to include all those libraries. One moment. ESP HTTP client. Yep. Correct. By the way, should I put it in the... Yeah, so... Should put it also in CMake to tell the compiler that we want to actually link this thing. Damn, it's already 10:30. Okay. Well, I hope, guys, we will be able to finish this thing. One moment, I just want to see how it works. Maybe to do some experiments. Yep. You know, it's quite hard to actually be able to do this embedded stuff and to actually be on time at work. So that's pretty hard, but I'm just gonna. I probably have time for it. So couldn't get host name for google.com. What? Google.com. Am I wrong? One moment. Just one moment. Yep, that is correct. Let's recompile it. Who cares? Yep. Who cares? Google answered with 0 code. Couldn't get hostname for google.com. Get our info return 202. Failed to open new connection. Failed to open new connection. Why is it happening before I even connected to Wi-Fi? That's like non-logical at all. So can it? Maybe because it's asynchronous and I should actually wait. Maybe. Okay, let's. So, like in free RTOS, how should I tell the task to wait until it's completed? That tells me to it forever. that's where I probably need some knowledge of FreeRTOS, because as you can see, as you can see, it tries to connect to Google right after I just process all that stuff. So I told the FreeRTOS that I want to queue the task to connect to Wi-Fi. It told me okay, it is queued, and then it goes to next instructions where it tried to connect, and it can't really connect because it's not really in Wi-Fi now. We can do it in a down way, I guess. We can do this like with the vtask delay. I hope it will help, but probably it should actually help. Let's try. But FreeRTOS is actually a very important topic, so I should actually learn it. By the way, I thought, like, I was thinking of not like shooting these videos every single day, but to do some theoretical days where I just explore some topics on my own and just then post my notes like on the Google Drive, and because sometimes it's hard to do some stuff without theory. More like impossible. Like connecting to Wi-Fi. So probably I should do some theoretical days also. Yep, monitoring. Okay, that's actually strange because it didn't even connect it here. Okay, maybe I should just reset it. Maybe it was a bug. Something else. Yay, it's connected. So now it just waits for 5 seconds and no server verification option set. Yeah, because it's HTTPS. Are there like any HTTP sites? More like HTTP one. Okay, I just want to know like HTTP sites. HTTP forever. Yeah, I want to actually go and make a request for HTTP forever. Will it just answer me? Okay. Let's go. Just a quick reminder, guys, stay healthy. Just a quick reminder here. Okay, connected. And 200 code. Here we go. Very cool. Very cool. But it actually wasn't Google, it was it was HTTP forever. But okay. HTTP forever answered with 200 code. Okay, fine. By the way, we can see the MAC address here. That's cool. That's cool. We can finally locate the MAC address. Okay, so the basic request works. Hmm. Probably the next thing I would like to do is to actually send some HTTP requests with inner headers. Or even to actually process the request. Yeah, process the request. I'm just gonna quickly look for the ESP-HTTP client read function. Because I guess it will be very helpful. ESP-HTTP client read, so read from the handle. The buffer is returned when call is time. Okay, is returned when call is timed out before any data was ready. So that's where we actually read the HTTP data or something like that. Okay, I just want to okay, let's assume the ESP32 acts like a server, like an HTTP server. Should I read the data that is sent to it with this function? That function's only for HTTP client outgoing requests. Pure ESP32 is running an HTTP, you should not use the server API. Oh, so that's a complete different thing. Dang, that's a complete different thing here. Handler. HTTPD. Let's just Google it. HTTPD ESP-IDF. Damn, that's a whole different API here for HTTP server. Yep. Okay. So basically, it's very similar to how we actually create web apps on basically every I know, like framework, basically on the for backend. For example, in Fast API for Python, it basically works the same way. Yeah. So you make the handlers for every endpoint, and internally they handle this logic. They call some function and just execute the inner logic with the data you send it. Yep. Okay. Okay. Okay, guys. Damn, it's already like 10:40. Guys, I probably should run to work now. Yep, so sorry to actually that I actually made a video that is not really 1 hour here. Well, I used to make them, but I guess it's next time 1.5 hour video or 1 hour and 20 minutes, something like that, just to stay consistent with the time I actually spent for learning embedded here. Yep, so next time we're gonna to try to actually code the server, the HTTP server, and send some requests from maybe some Python script on my personal computer. Yep, so today video is kind of short, kind of more theoretical one, but we actually made some cool thing. We actually send an HTTP request from ESP32. That's cool. Yeah, that's not a big deal, I guess, but that's how consistency work. You basically do small stuff every day, small experiments, and then you just learn how it works. So that's pretty cool. That's pretty cool. So tomorrow, HTTP server, And I hope you enjoyed this video, guys. Thanks for watching. I don't know, subscribe, hit the like button. If you have any questions, any suggestions, you can write them in the comments. I will be eager to answer them. Subscribe to my Telegram channel, where I sometimes post some materials, for example this wonderful guide, or I don't know, like this cool guide too, yeah, which I just find useful. So okay guys, hope you enjoyed. See you tomorrow. Bye. Okay.